everyone. I wanted to take just a quick minute and go over a few problems from the PST that I've received a lot of questions on. And hopefully that will help clarify for any of you who are still struggling with these particular problems. And hopefully if you had any other questions, we got to those in class today, or you could ask right at the beginning tomorrow. So the first one I wanted to look at is number 1. And number 1 is not a difficult question, but I just want to clarify some wording. In fact, I'm going to pull the whole book over here so you can see what number 1 says. Number 1 says, evaluate the following to the nearest thousandth, and it's asking for cosine of theta. Okay, so the question wants to know, what does cosine of theta equal? Okay, so I want cosine of theta equals something, and this right here is my answer. Okay, I'm making such a big deal about this because this is the one that we've been mixing up kind of consistently. Cosine of theta, going back to that triangle, cosine is adjacent over hypotenuse, so it would be 24 over 25. And in my experience, most of you know that. You'll be fine for that. Okay? What we do not want to do right now is we do not want to take the inverse cosine of 24 over 25. Okay? Because that will no longer be answering the question, what is the cosine of theta? Okay? The cosine of theta is this right here. Now, in your textbook, I believe they turned this thing into a decimal. 24 over 25 is 0.96. And that answer would be okay too. Okay? But some of you are then going, okay, the inverse cosine of 0.96 is, and then, sorry, I should have had a calculator ready. Some of you are saying, oh, the answer is 16.2, or I guess 16.3. If this is your answer, what you really found here was the angle measure. You found theta, okay? So this is the theta measurement or the angle measurement, but that's not what the question asked for. The question said, what is the cosine? And the cosine is 24 over 25, otherwise known as 0.96. Either one of these answers would be acceptable. This is not the right answer because that's not what the question is asking for. And the question I keep getting from students is, how will we know? Well, you know because this is asking you for cosine of theta, and this is cosine of theta. Okay? If you were asked to find what theta was, if the question said, tell me what theta equals, that's when you would give this answer. Okay? So it's all in the wording of the question and what it's asking you for. Okay? If you do this, it's like I ask you, what's 2 plus 5? And you tell me, well, 2 minus 5 is negative 3. Okay? It's you doing something different with the information that you're given. The question is asking you for this. Okay? All right, I'll hop off my soapbox about that now. I want to look at number 6. Number 6 says, sine of 57 equals sine of what? Okay, and it tells us that we can't cop out and just say that x must be equal to 57. That's not quite how it works with trig ratios. We did talk about this relationship, and it's an important one to kind of understand, that if you're looking at the circle and I draw a line at 57 degrees, okay, so this is 57, then this angle is going to have a cosine, cosine and a sine, okay? And my question is, where is there another angle where the sine is going to be exactly the same? Where would I have another point where the y coordinate is exactly the same as this one? Well, that would be if you go straight across the circle this way, and for sine values, they're always going to be the same, going left to right. This angle here, the coordinates would match almost exactly, except the cosine would be negative. Okay, so negative c comma s. Okay, and so to figure out what angle this is, I know that this is 180 right here, and this must be a 57 degree angle because this is a 57 degree angle. So I'm going to backtrack from 180, 57 degrees. I'm going to go 180 minus 57. And I get that that's 123 degrees. So if you check in your calculator here, sine of 57 is 0.8386. sine of 123.8386. Okay, the exact same value because of this relationship going across the circle. Okay, so anytime you're trying to find two angles that have the same sign, which is what this is asking for, two angles that have the same sign, you can find the one angle and then subtract from 180 to get the other. Okay. Okay. I want to look at number 13, and actually this one's important because number 13 I didn't technically assign to you, and then after I looked at your test, I realized number 13 would be a good one to look at. If you were in class today, we talked about number 13, so you've probably already seen this, but this gives you four statements, and I apologize, just give me a second here to write these in. Sine of 90 minus theta equals cosine theta. B says sine of theta plus 360 equals sine theta. C says sine squared of theta plus cosine squared of theta equals 1. And D says cosine of theta plus 180 equals cosine theta. Okay, and what this question is asking is, of these four, which one is not always true? Okay, so I hope that when you see A and C, you eliminate those off your list right away, because these were both properties that we learned in this chapter. Okay, this one is that one that we said where if you have a right triangle, these two angles must add up to 90. So if this up here is theta, then this angle down here would be 90 minus theta. Okay, those have to add up to 90 because then you've got another 90 there, and then that makes 180 total. And we said that in a right triangle, the cosine of one angle is always equal to the sine of the other. Okay, these two are equal to each other. Okay, and so that's really what this is getting at, is if you do the cosine of one angle, it's equal to sine of 90 minus the other. And then this was the Pythagorean identity that we learned back in the beginning of this chapter. So both of these are true all the time. Now we're down to B or D. And I want you to think about what theta plus 360 is really talking about. Okay? On the unit circle, if I pick any point, that's my theta, right? And I add 360 to it, that's just going to land me back in the exact same spot. So is it true that sine of this angle is equal to the sine of this angle? Well, yeah, they're in the exact same place, right? They're exactly the same coordinate, and so your sine value would always stay the same. So this one is also true, which leaves us with D here. But let's make sure we understand what D is saying. If I take theta and add 180, that's transferring me halfway around the circle. So theta plus 180 would land me down here. And is it true that the cosine here is equal to the cosine here? It's not, because the cosine is your x value. This one down here would be negative, and this one over here would be positive. Okay, so this one is the one that's not a true statement. Now, if I slapped a negative sign in front of that cosine theta, then I'd be okay, but that's not what the question was asking. Okay, and then there was one more from the PST that I wanted to make sure we talk about, just because I got a question on it a lot today. And that was number 18, sketching the graph here. So with 18, it wants me to graph the function y equals cosine x, okay? And to do that, I'm going to sketch just a tiny little unit circle. And it's tiny because I really only need these coordinates. 1, 0, 0, 1, negative 1, 0, 0, negative 1, okay? Also, I'm assuming that you know this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. I'm just going to put a pi in here just to keep you thinking in radians, okay? And let me draw my graph here. Now, it says in the problem that it wants me to graph starting at negative pi over 2 up to 3 pi over 2. So I'm going to number my graph in radians and in terms of pi over 2. So this would be negative pi over 2. That would be 0. Here would be 1 pi over 2. Next up would be 2 pi over 2, and 2 pi over 2 is really just pi. And then next up would be 3 pi over 2. If I did one more, it would be 4 pi over 2, otherwise known as 2 pi. But the question wanted me to go from here to here. Okay, so I'm just doing these 4 points. Okay, which is good because those all show up on my circle. And even though our graph starts here, I'm going to start at 0. Well, and first I'm going to start by making sure that we're looking at our cosine values. Cosine is your x values. Okay, so because I'm doing cosine, I want to do the x coordinates. So starting at 0, my cosine is 1. Okay, and then when I jump to pi over 2, my cosine is now 0. When I go to pi, my cosine is -1, which would be down here. And then when I go to 3 pi over 2, which is down here, my cosine is now 0. Okay. And then if you can kind of follow the pattern backwards, middle, down, middle, up, this one, -pi over 2, would go in the middle. Okay. Because -pi over 2 is really this point right here. It's going backwards by pi over 2. So then I'm just going to draw this in. Okay. And that right there is one full cycle of the cosine graph. Okay, that's what your graph should look like there for 18. Okay, the range would still be from +1 to -1 because I know number 19 asks about that. Your x-intercepts would still be starting at 90 and then adding 180. It's just in radian form. Okay, but the graph itself is what the real point of this question was. Okay, and on your test, you do have to draw a graph, but it is drawn for you. Like you just have to label the points. Okay, so the graph itself is set up. That's what I meant to say. Okay, extra bonus for those of you watching this video right now. There is one problem from the chapter review I kind of want to make sure we talk about, and that is number 22. So I'm no longer in the PST. I'm heading over a page to the chapter review, and I'm looking at problem number 22. Okay, and 22 says, find 2 values of cosine theta if sine theta equals, where's my problem? If sine theta equals 0.36. Okay, so I'm going to show you 2 different ways to go about this problem, and either one of them is okay with me. Method number 1, okay, is let's work backwards and find what theta is, because if I can find what theta is, then I just have to take the cosine of theta, okay? So I'm going to do an inverse sine of 0.36, and I get about 21 degrees, okay? So I'm going to start by doing inverse sine of 0.36, and that leads me to the fact that theta is 21-ish degrees, okay? And so if I think about this in terms of a circle, you know how I love my circles, that's going to be like here, okay? It's going to be really low down here. And I know that the coordinates at this point are going to be whatever the cosine is and then 0.36, okay? Well, there's another place where the sine is equal to 0.36, and that would be straight across at this angle over here, okay? Now, I could figure out what that angle is equal to. I know it looks off because, well, I'm a terrible drawer and my circle's way bigger over here, but these angles would both have the same sine value if this triangle or if this circle was drawn correctly. So this is also something, comma, 0.36, okay? And I can find the cosine now by just doing cosine of 21 degrees. Well, cosine of 21 degrees, let me make sure I'm in degrees here. I'm in degrees because this was a degree measure, is 0.934, okay? And so we could work backwards and figure out what this angle is and find the cosine of it, but we don't actually have to, because if you know the relationship between these two and this point over here, this coordinate is going to be exactly the same, except that will be negative 0.934. Okay, so I did just to recap here, I did the cosine of 21 degrees, and I found that it was 0.934. And then if I did the cosine of this other angle, which is 180 minus 21 degrees, I would find that it is negative 0.934. Okay, and so right there are my two values of cosine theta. Okay, and it's always going to work that way. If I can find the cosine of one of them, then I can just do a plus and minus, because that's what's going to happen when you jump over to that twin value. Okay, so that's kind of just using the circle in our practical knowledge. The second way is sort of using the method that we learned in class for this. When I asked you this question before, what we used was the Pythagorean identity. And I kind of let you slide on a pretty important detail with the Pythagorean identity because I just didn't feel like we were quite ready for it yet. So 0.36 is going in for sine. Plus cosine theta squared equals 1. Okay, let's go ahead and square 0.36. Oops, 0.36 squared. And I get 0.1296. Okay, and now I'm going to subtract. I'm going to go 1 minus 0.1296. And I get 0.8704. So now I have cosine theta squared equals 0.8704. And then from there, we're going to take a square root and square root. And up to this point, what we've always done is just taken the square root and gone on our merry way and said, oh, my answer must be 0.933. Okay, close to this. There was some rounding involved. But here's the thing, and this is what I let you slide on before when we did this. We just took a square root in the middle of an equation. Okay, I can't believe none of you called me on this when we did this problem. We took a square root in the middle of an equation. What does that mean about this answer? It means that it should actually be plus or minus 0.933. Right? When you take a square root, you should get a positive and a negative answer, and that comes from this. It comes from the fact that you could be at either one of those angles and have that sine of 0.36, and the cosines would just be plus and minus of each other. So our two values of cosine are just the positive and negative versions of this number. And I don't care how you get there. It doesn't matter. But you should be able to use one of those methods and problem solve your way to find the cosines. Okay. I think that was it, and nobody submitted any more questions that they were asking me to go over. I guess one more thing I will clarify real quick, just because, again, this is what I started with today. But if you look at like 7 through 9 over here in the chapter review, this is asking you for the sine of theta and the cosine of theta and the tangent of theta. All of those things are fractions. This is asking you, give me a fraction, give me a ratio, approximate the trigonometric value. That's what these are, okay? Over here, see how it says find theta? Find all values of theta? That's where you're using an inverse because you're finding an angle measure, okay? This did not tell you to find theta. It told you to find sine theta, okay? That's the big difference that you want to look for. Okay, that is really it from me today. Good luck studying tonight for your test. I will try to get here a little bit early tomorrow morning to catch some last minute questions, but we should be able to walk in and just be started and ready to go. Okay, good luck.